All right, here we are in part 2 of the procedural buildings tutorial. In this one, we're going to be addressing the rotation of each of these walls right here, because right now they're all facing the same direction. It's hard to see because these are all pretty much symmetric objects. But if we just come in here and add in a cone real quick and rotate it so that it is facing in just a particular direction. Let's connect this over here. That's not what we want. Connect our cone over our instances, get rid of all that, and rotate our cone 90 degrees so that it's all, you can see they're all pointing in the same direction right now, all like that. And what we want is for each wall to be facing outwards. So like, for example, you know, these right here facing the right direction like that, and then we'd like this wall to face that way, and so on and so forth. So that's what we're going to be doing in this video. Right now, let's just go ahead and take all of these that we created before and just Control G, create a group for those. And just set those aside for now. And same thing for all this stuff right here. I've tidied up a little bit. It looks a little bit cleaner than it did at the end of the last video, if you watched that or not, I don't know. We'll go ahead and create a group for these as well. Drag that over there. And we'll set this aside as well. In the end, we're going to use this normal and separate XYZ for what we're going to be doing right now. But for now, I'm just going to set it aside and we'll just create a new one for that, for what we're going to be doing right now as well. We'll just set both of these aside so that we can actually work with this right here. So right now we're just using these cones as kind of arrows to show us what direction each face is pointing, and we want to rotate all of these faces so that they are going to be facing the right direction. We'll be rotating everything along the z-axis like that. And the way that we are going to be doing that is, again, with more Booleans. We're going to use some Booleans to select each face, each side going on the side of the building like that. So for this, we'll use some more compare nodes, and we will be using the X and Y components this time. Since this is going to be agnostic for the height of this, it's just going to be based on which side it's on. So let's go ahead and use our X right now. We'll leave it on greater than and put it on greater than 0. And let's just see what happens. If we take this and put it into the selection, we can actually see which ones it is working on. Right now it's working on this one because this is our positive x-axis. So we can go ahead and, I'll just label this for you. Positive x, positive y, minus x, and minus y. It's hard to draw with your mouse like that. Anyways, so this is what we're doing right now. For what we have selected, we have our x normal, the normal for each of the points on our base mesh over here, wherever that normal is greater than 0, which is going to be any point along this wall right here. If we duplicate that and set this to less than, then it's going to be taking this one right here, duplicate it like that, and just do the same thing for y. Maybe do the same thing for y. And that should give us the positive y and negative y. So let's go ahead and rename these to positive x, and rename this one to negative x, positive y, and negative y as well. And then we will get into how to actually utilize each of these, because right now we can select for each one, but we can't actually combine them all together. And to combine them all together, we'll do a similar thing to what we did for our selections. We used a bunch of switches, and we'll just combine the Booleans for each of these like we did before. This time though, instead of doing an integer, we're actually going to set this one to vector. And that way we can take the output of this, whatever that is, and feed it into the rotation here so that we can actually rotate what we've selected. So let's reset that and just connect this one over there. Let's connect our positive x and see what we've got. So right now it's set to 0, 0. And if we rotate this you can see it rotates everything that's not on the positive x-axis. And this one is rotating just everything that's on this wall right here. So right now the alignment is correct for this one, so we don't need to do anything with the true value. And we can just add in our next one for the negative x. Plug this into the false like we did in part 1. So this will rotate everything that's along the negative x-axis. And if we do this, it'll rotate the stuff that's not on one of the x-axes. And the reason it's not rotating, the positive x is because we are already controlling that with this switch. And again, it looks backwards rather than looking forwards, if that makes any sense at all. So we have it right here, so we can just rotate it 180 degrees. But if you'll notice, it doesn't actually, if we type in 180, it does a weird thing like that. That's because here it's actually using radians rather than degrees. So you could, do this by typing in 2 pi, 2 times pi, if I do that correctly. Nope, it'll be 1 times pi. So if we just type in pi, it'll rotate it the correct direction. That's radians. I don't like dealing with radians, so we are going to use a rotate Euler. Now, as for why it's this node, I honestly have no idea, but this is just the node that works, and it puts it in degrees, so we can type it in degrees like that. And so then we'll duplicate this setup twice more and hook these up in series. So now we're going to be selecting for positive y. So our positive y, now you can see it's rotating along there. We'll rotate this 90 degrees and select for our negative y and rotate that one negative 90 or 270 if you will, but I'll put it at negative 90. All right, so now our walls are facing the right direction. Our roof right now, this center roof piece, it's not facing the right direction, but it honestly doesn't matter what direction that one's facing because in the end, it's just going to be a symmetric thing anyways. So it's not really important what the rotation of these in the center is, but these are all facing the right direction. But now you'll notice that on the x-axis, both of our x-axes, we have all 4 of the vertices, and for the y-axis, we only have the inner 2 ones. And what we would like is for it to be in groups of 3. So like these right here will be facing positive x, facing out like that, and these 3 facing out like that, and these 3 and these 3 is kind of what we want. That way, when we're building our corner pieces, we can know that the corner is always going to be facing such that, they'll just be the same. We want them to be the same. So that when we're building the corner pieces, we don't have to worry about like, oh, is it a positive X corner piece or is it a negative, thing, whatever. We want them to be the same. So we also want to rotate these right here so that they fit with these groups that we have made. And the way we're going to do that is by just kind of removing these 2 corner pieces from the X selections, because right now all of the ones along positive X and all of the ones along negative Y are going towards those. So we want to remove it from this selection, because right now, if you think of Booleans as outputting 1s or 0s, then this right here, this Boolean that we have where we're comparing floats, it's outputting a 1 for all of these into this switch. So this switch is giving us a 1 for all of these, and therefore it's going with true and not rotating that. And what we want to do is convert this vertex and this vertex into a 0, so that then they get passed on back to the previous level, which is why we say it's looking backwards. We want to say don't look at it here on this switch, look at it on this switch right here. This is the positive Y direction. This is where we want to actually use the Boolean, because if we take a look at the positive Y alone, you can see that it actually does include this selection. It's just this selection is being overridden by the X selections because they come first. Anyways, that was a very long explanation of why we're doing this, but we don't want that. So we'll do this with not a Boolean math node. We'll take the input of our positive x and the input of our positive y. And what this does is it takes the intersection of positive x and y, so this row and this row, and it says it outputs a true, so a 1, for wherever they intersect, which is this one. This is the only one that they intersect on. And what we want to do is subtract this, because now we have a 1 here from this one and a 0 everywhere else. We want to subtract this 1 from the original selection of positive x that we have right here. So we'll use another Boolean math, set this one to subtract, and we will feed our original x into there and our subtraction there. And what this will do is it will take our original selection of positive x, this group right here, and it will subtract the intersection of x and y, this one right there. So now it is outputting, if we just look at it in our there, it's just going to output these 3 right there, which is what we want. So we'll remove that and swap that right there, and now that is going the proper direction. And then we'll just duplicate that for the other corner, but using negative x and negative y. Take those there, take that, that, and if we do that, now this one switches the proper direction as well. So now all of our faces, all of our walls are facing the right direction, and when we're building our corner pieces, we can say put the window, you know, we're going to have little windows. So imagine a cube right there. We're going to have a window right here and a window right there, and that's going to be the same as it is for all of them, so we don't have to worry about selecting different ones. All right, one last thing. I know I said this was just a rotation tutorial, but we are going to get rid of these bottom points right here, these bottom instances, because you're not going to see them. It's just going to be extra vertices that will slow down your render a little bit. And this already has quite a few vertices, not as much as the landscape tutorial, but you know, you want to save vertices wherever possible. So let's go ahead and just reconnect our original node set up. Let's take our geometry, plug it in there, select instances, and plug our index back in. So now we have all these. We're going to get rid of these 4 cubes right here. So let's go into our selection right here and just add in another compare node that we will hook up to the Z component. I guess this one's the Z one. It's not labeled well. I should label it. When you're working with node groups like this, you should label it. I believe this one is the X normal. This one's the Y normal. And I believe this one to be Z. We'll see if I'm correct. So yes, connect your Z normal up to here. And what we want is select all of the vertices for which the Z normal is exactly equal to -1 and epsilon of 0. Because, you know, all the ones along the edge here, the Z is going to be, you know, facing somewhat out at a diagonal, so it's not going to be equal to 1. But the ones in the middle here are going to be equal to 1 exactly because they're just straight down. So we've output that right there, and that's all we need. We just carry this on through there. Let me just organize that a little bit. Tab back out there and take our result here, and that is selecting the right ones. We want to do the opposite. So let's set this from equal. We'll set it to not equal there. So everything is being instanced right here. All the points have instances on them except for this little section right here. No matter how big this gets, it will always be everything except those right there. All right, so that is the tutorial again. This one's quite a bit shorter than the previous one, I think. It felt certainly more ranty than the last one. Anyways, the next one, I think we'll start working on the actual modeling of our windows and all that stuff, start working on the base instance meshes that we can use instead of all these random shapes that we have here. And I'll see you on the next video. In case you didn't watch my message on last week's video, I have made a Patreon. That's right, at patreon.com/ltfilm. You can purchase your way into a few little extra benefits, like getting the Blender files for things such as the procedural building, or even the landscape that I did way back when. Lots of other benefits. You can vote on videos. If you $25 a month, you can actually talk to me personally, one-on-one, things like that. So yeah, help support the channel a little bit, and I'll see you on the next video. Bye-bye. All right, if you've stuck around, then you are here for me to clean up the node group here again. It's another process. And you get to hear me just rant again, because that's what I do, apparently. Apparently that's my shtick. I don't know. I'm recording this on the same day as part 1. So, I don't know if anyone's staying around to listen to this stuff, because the first one hasn't even been released yet. So I'm just recording because I can, because I love to listen to myself speak, and you get to hear pure, unfiltered me. I know it's horrifying, but maybe you can find some value in this, just kind of seeing how things can get organized. Don't forget to save, everyone. I never save when I'm doing these tutorials. I don't know why. For some reason, I seem to have a thing against saving in the middle of tutorials. But I'm just kind of cleaning things up a wee bit, making it all look kind of decent. Otherwise it could be a mess, and nobody wants that. Scale Y0, and we'll go ahead and add that one in there. Again, like I said last time, if you listened, is that very important thing while cleaning up stuff like this, not really important, but just kind of makes it easier, is using your scale Y and scale X 0 to organize things into rows and columns. And of course, right angles are so important to me, as you already know by this point if you're sticking around. Trying to figure out what layout actually works really well here. Because since there's a lot of crisscrossing patterns, things can get a wee bit messy. And actually, this is a different arrangement than the one I used in the original node setup that I used for the picture at the beginning. This is a different arrangement and different numbers. So I'm also kind of just having to figure this out as I'm going along, because I don't know, because the way I organized it before is a little bit different than before. So I'm looking at an image of the original node setup and how I kind of laid it out and organized it, and it does not apply because it's not the same. That makes things difficult for me. Let's see. Oops, don't want to do that. Take this one, move it over here. Scale Y, make them flat. Move it up there. Take that. Actually, let's get rid of those. Put that there, move that. And something like that looks pretty decent. Oops. All right, and one more this node right here. I think we want it to be kind of close to that one. Let's move these right here. And voila. This one's a lot shorter. It's a lot easier to work with this one, I hope. And move that one down to make it even and a right angle. There we go. I think that's a pretty clean setup. I'm sorry for my ranting. I mean, if you're sticking around at this point, you're probably wanting to hear it, but it doesn't make me feel any better knowing that I'm subjecting you to this. And like I said before, we are sharing these with this one, so I'm going to reconnect everything. I just need to figure out how I'm going to do it. All right. So this kind of goes to the big overall or overarching plan here. Let's replace those. X to X, Y to Y, and Z or Z if you're one of those British people. If you're British, I apologize for my insensitive comments about British people. Anyways, some vaguely right angles here. Something like that. These three we want to carry up, and this one, put it right there. Let's make a selection where we want, it's going to be even with one of these just because straight lines are better than weirdly angled lines, which are just things. I don't know. I mean, if you're listening still at this point, you're like totally awesome. Maybe you just have it in the background and you're not really listening. That's okay, I forgive you. That didn't make sense here. Okay, there we go. All right, so we have those kind of like that. Let's flip these because that's what I did before. Even though I just got finished saying that it doesn't matter because it doesn't match, but this is what I did in the original. I went X on the inside and Z on the outside. So you know what? It's what we're doing. We don't need to do it. We're just going to do it because we can. All right. Okay. Let's go there. That one goes there roughly. Okay, now select all these. Scale them along X so that they're a straight line. And get these leveled out with the node that they're connected to. So it looks vaguely right. There you go. All right, that is relatively clean. There will be much more that goes into this in the future, but subscribe to my Patreon. I don't know. Like I said, I'm doing this before I did the other one, so I still haven't made the Patreon yet. Maybe I've made it by now, by the time you see this. I don't know. Anyways, that is it. It's clean. I'm done with it. I keep saying I'm done, but then I keep messing with it. I'm sorry. I can't help myself. I have to do it. I'm compelled. All right, there we go. I'm done. I'm not going to touch it anymore. Have a great day or night or whatever time of day you're watching this, and I'll see you on the next video where we actually start making some windows. Bye-bye.